Yeah, in this session, I am going to explain Boolean algebra. Okay, you just see this is very interesting topic. Actually, the theory of the Boolean algebra has been proposed by the mathematician Boole. Okay, initially, actually, he has used preposition logic to actually uh, uh, to describe the Boolean algebra, and propositional logic as for example and or, and this was and or and negation. Okay, this was used to develop the electronic circuit in the physics, in the field of the physics. Later it was used later it is used in the field of the computer science and application to develop the electronic circuit. Okay, fine. You just see what is Boolean algebra. First of all, you have to understand what is Boolean algebra. So very basic question is, what are the differences between Boolean algebra, an ordinary algebra, and Boolean algebra. Okay. What are the questions? The question is, what are the differences differences between an ordinary algebra and Boolean algebra. Boolean algebra. Okay. You know, I'm just defining briefly ordinary algebra here. Ordinary algebra, and this is Boolean algebra. Boolean algebra. Okay. In an ordinary algebra, actually 0 and 1, 0 and 1, 0 in an ordinary algebra, 0 and 1 is used as digit. It is used to express the digit. Okay, this is number 1 I can give here. And but in case of the Boolean algebra, 0 and 1 is used for false 0 and 1 is used for false and true or the off and on. Okay, 0 and 1 is used for false and true or off and on. Okay, second difference is what? Second difference is the operator operator used in, I am briefly writing here, operator used in an ordinary algebra is plus, minus, into, and division. But in case of the Boolean algebra, the operators used are basic operator used are plus, and, this is 2, this is and this is the basic operator, and this is or, and this is not. Okay, these are the basic operator used in case in expressing the Boolean algebra. Okay, you just see it, and or and not. Okay, you just see what will be here. Now I am rubbing this part, it is not required right now. You just see what will be here. Next part is what is Boolean algebra. I am just going to define what is Boolean algebra. Okay, you just see. You just see here. What is Boolean algebra? This is the question number 2. What is Boolean algebra? Or define Boolean algebra you can write. Okay. You just see. Actually, Boolean algebra is a branch of mathematics which deals with the Boolean algebra. Boolean algebra is the branch of the mathematics, branch of the mathematics branch of the mathematics branch of the mathematics which deals with the study of binary number 0 and 1. Okay, clear? The logical meaning of 0 and 1, the logical meaning of 0 and 1 are false and true. False and true. This is also false and true. 0 is used for false and 1 is used for true. This is also used for expression of the this is also used 0 is used for off and 1 is used for on. Okay, 0 is used for off and 1 is used for on also. Okay, actually initially he has used the prepositional logic to develop the circuit. Is that clear? You just see here, and that's all. Prepositional logic he has used this is actually this is actually and this is also represented by dot. This is represented by or, and this is also represented by plus. Okay, and this is negation. This is called actually negation. Negation, negation, or complement. This is used for. Okay, this bar is also used for negation or complement. That is here. That is here. This bar is also used for negation or complement. And that is also used as actually this symbol is also used. Okay. So both the symbol is used to express the actually this is called NOT gate actually. This is also used to express the NOT gate. You just just remember these things little bit. Okay. Fine. That's it. I am rubbing this part. Uh, that is the actually scope of the Boolean algebra. I have defined in my sense of the domain or range. Okay. You just go through properly. Otherwise, this is very important part. That is why I am focusing on this. Okay. You just see here. Actually, next part will be your what? Next part is here. There are some logic gate is used to. The logic gate is required to actually to make understand Boolean algebra. And what are the logic gate? Basic logic gate is used here. Actually, here the basic logic gates are used here. You just see here basic logic gate. Okay, logic gate is used here. These are the basic logic gate. I am just defining this basic logic gate. What is the basic logic gate? Basic logic gate is and, or, and not. Okay, clear. You just see here actually these three operators, three operators and or not. Three operators are used to express the basic logic gate. Its symbol is, it can be symbolically represented as dot, and this is plus, and this is represented by actually bar, or you can express in this way. Okay. So first of all, you just identify how you will identify the operators here. Okay. This is called basic logic gate. Okay. You just see what is happening in case of first. I am just defining this first one, and gate. Okay, this is called actually and gate, A and D and gate. You just see how this can be expressed. And gate actually suppose it is represented as in this way. I am representing actually R shows the relation between A and B. There are the two input variable or variable A and B. Okay, and there is a symbol dot which is used to relate A and B. Okay, this symbol is known as, actually this dot is known as here and. Okay, clear. This dot is known as here and. Okay, and you just see actually first you will see you just see the truth table. How the truth table I am going to draw here. Okay, here we have just deciding this to express AND gate, that is A and B, and the relation shows between A and B is this in this way. Okay, so you just see here, suppose actually there are two variables. That means it is represented for two inputs. Okay, there are two variables, so it is represented for two inputs, and inputs are here inputs are here 0011, and this will be a single 0 single 1 single 0 single 1. When we shall multiply it actually multiply a and b, or using the operator and operator, then this will be a 0, and this is 0, and this is 0, and this is 1. This 0 into 0 0, 0 into 1 0, 1 into 0 0, and 1 into 1 1. Okay. You just see here the sequence. You can you can test whether you have done right or wrong. You can verify. You just see how it happens here. 000 here, 000. This is the sequence. This is the arrangement of the digit here. 000, and this is 10, and this is 100, and this is 111. So you just see here, this is in the arrangement of the digit, binary digit, in ascending order. Okay, the order of the binary digit is in ascending order. Okay, clear? From lower to higher value, from lower value to higher value. This is 0, this is 10, this is 100, this is 111. This is actually, this is the tricks. This is the tricks to know, to judge the truth table whether you have done right or wrong. Okay, nothing else. Okay, that part I am rubbing. Yeah, that part I am rubbing just to make you understand. I have done so far, and you just see here logic diagram of AND gate. This is called logic circuit diagram, or you can say logic diagram directly. Logic diagram of AND gate. You just see. This should known to you, otherwise it is very difficult to understand the concept of the Boolean algebra, because at every steps this will be every steps of the calculating Boolean variable or Boolean values, it is required. That is why I am making understand to you. Logical diagram of AND gate is, you just see here what is how it will be. AND gate, that means you will use the actually in this way. Okay, and this is the input, as A and B are the input, and output is the R is equal to, this is the output actually, R is equal to A and B. Okay, this is AND gate. Okay. This is the logical diagram of AND gate, nothing else. Okay, so this becomes here, I think AND gate we have done. This is the input, and this is you. One thing you will remember, if the input will be 2, here the input, the number of actually how you will use here 0011. You should know little bit, but I am just going to make you understand the thing, make you clear this thing. Actually, input is here. Number of input is here. What? Number of inputs is equal to 2. Therefore, the digit required. Here the digit required. Here the digit, binary digit. Sorry, binary digit, or you can write number also, number, to find the output is equal to binary digit. In the first bracket you will write number. To find the output is equal to, that is equal to 2 to the power n, and just n value is equal to 2 here. So I will put here 2 to the power 2, that is equal to 2 into 2, that is equal to 4. The 4 binary digits are required. Binary number are required. That is why I have used. In binary number, only 0 and 1 can be used. Okay, to represent the logic. Okay, So we have to divide the binary number into the equal number of zeros and one. Okay. Actually, this is the tricks to remember. Remember the thing clearly. So I have used here double zero double one. Okay. We can divide 0 and 1 into the equal number of zeros and equal number of ones. So in that case we are getting here double zero and double one. And you know, binary it again, this half has been divided into half number of zeros and one. So there are two zeros, and that becomes single zero and single one, and this becomes single zero and single one. In this way you can understand. Okay, I think it is not required to understand again and again while I will go to define other logical gate. Okay. You should remember this concept that will be very helpful to you. It is not written in any book or anywhere. Just for your convenient, I have used this logic to make you understand the thing. Okay, that's fine. This logic you will use in every case of the defining the logical circuit. Okay, not in only this circuit. This is the general logic you will use everywhere. Suppose there are three inputs A, B and C, then there the required number of binary digit, binary digit or number to find the output, that is equal to the power n, that is equal to the power 3, that is equal to 2 into 2 into 2, that is equal to 4 to the 8. Okay. Or if there will be 4, then it will be 4, then 2 into 2 into 2, 2 to the 4, 4 to the 8, 8 to the 16. In this way you can use this formula generally for defining the output while the inputs are given. Okay, that's fine. I am having it, not required. Okay, you just see here. Actually this is very easy, but you have to be very careful, otherwise you cannot understand. Okay, you just see, next is OR gate. I'm doing here OR gate. OR gate. OR gate, actually the symbol is here. Symbol is used as plus. Okay, this is the symbol to define the OR gate. You just see here how it will be used here. You just have to see here. First of all, I am going to make a truth table. You just see there are two inputs. Here I am writing truth table. Here I am writing truth table, and here I am writing logic circuit. Logic diagram or logic circuit diagram, you can write in both way. Logic diagram I am writing because it is understandable to you. Truth table, you just see here, there are the two input. Okay, truth table, there are the two input A and B, and R is equal to A or B. Okay, you just see here, when I will take two input, double zero, double one, and this is single zero, single one, single zero, single one. Okay, this is 0, and this will be 0 plus 0 is 0, 0 plus 1 is 1, and 1 plus 0 is 1, and 1 plus 1 is 1. Okay, so 0 plus 0 is 0, 0 plus 1 is 1, and 1 plus 0 is 1, and 1 plus 1 is 1. And logic diagram you just see here, actually in this way, little bit, and this. Okay, this is the logic diagram. A, this is the input A and B, and this is the output R, which shows the relation between A plus B. Okay, so this is OR gate. This is OR gate. Okay, and truth table I have drawn already. So two things is very important. One is truth table, and another is logic diagram. Okay, now next one will be here. I am rubbing this part I am rubbing, and you just see. Actually, this was not required to rub yes, because this will require again and again. You just see here. Now you just see here, not gate, okay, NOT, not gate, or it can be expressed as bar or complement. In both way, it can be expressed. You just see here. Here the truth table, TT, that means truth table, and here is the logical diagram. Okay, because entire Boolean algebra is based on this. Okay, if you will not do this, you cannot understand the Boolean algebra properly. I have to clear again and again, and that will be very actually painful experience for me as well as for you also. Okay, so just you see here the truth table. What is the truth table here? How we will draw here? Here I will take only one input A, and here I will take A naught. Okay, A naught or A this. In this way you can also express. Suppose I am taking a 0 and 1. Why I have taken a 0 and 1 only? Because here the input is only 1. Input n is equal to 1. So that is equal to required binary digit or binary number or digit you can write, that is equal to 2 to the power n, that is equal to 2 to the power 1, that is equal to 2. 2 are required only. That is why I have taken a 0 and 1. And the actually complement or actually negation or you can say not gate of this, is 0, 1 and 1 will be 0. So in this case this will happen, and I am going to just draw the logical diagram. You just see a logical diagram, how I am going to explain you. You just see this is, and you just give here knot or you circle, and this here this will be here, and this is here A, and this is here R, shows the relation that is equal to R is equal to A naught. Okay, so this here logic diagram, this becomes here logic diagram, and this is not gate actually. Okay, so this I have done. Now and or and not gate I have done so far. Then I will do here next gate. Next gate is used as and or and not gate happens. Next gate is I am going to use a NAND gate. Okay, that is NAND NAND gate. NAND NAND gate. Okay, that is NAND gate. Okay, NAND gate is how NAND gate will be defined. Just actually now I am closing the session. In the next session I will explain NAND. In the next session I will explain and NAND, NOR, and JOR, and XNOR. Okay, in the next session I will explain these four actually 1, 2, 3, 4 gates. Okay, a little bit I am making you understand these things here. And actually this is called the universal gate. Actually this is called I am using red ink here. This two is called universal gate. Universal gate. Why it is universal gate? Because all the basic logic gate can be prepared or defined or expressed by these two NAND gates. That is why NAND gate and NOR gate is known as the universal gate. Why NAND and NOR gate are the universal gate? Because all the basic logic gate and or and not, and or and not can be defined, because all the basic logic gate and or and not can be defined, or you can or expressed, or you can use can be defined or expressed or represented 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 and or and not can be defined or expressed or uh, represented by NAND and NOR gate. NAND and NOR gate. So that is why NAND, that is why NAND and NOR gate is known as universal gate. UNIVERSAL, universal gate. Okay, clear? So you now I am closing the session. In very next session I will explain these all and the Boolean algebra concept. Okay, fine.